so hard to learn their language, can't we just teach them ours? Isn't that an easier way to have an interspecies conversation? Maybe. For decades, scientists have been working with apes to teach them American Sign Language in order to learn more about both the species and the origin of human language.
So the first chimp was Washoe. She was wild caught by the Air Force. They were collecting chimps for the space program. Instead of going into space, she joined this sign language project, so she was raised like a human child, and all of her caregivers use American Sign Language.
Washoe was able to learn over 200 signs, talk to scientists, and even taught another chimp how to sign. More studies popped up, most famously with Coco the gorilla, and for a moment, the lines between human and animal blurred ever so slightly. Some were still skeptical, though, arguing that these apes were just mimicking the signs for reward instead of voluntarily conversing. And other studies were done that showed apes talking amongst themselves with signs and having private conversations with each other. They seem to be using language voluntarily. Now, even though great progress has been made, some in this field do feel uncomfortable with the idea of bringing new apes or any animal into captivity to study.
As someone that's been doing this for a long time, I feel that this research should never be repeated. But the chimps that do have sign language, I feel that it's important for us to continue to document it and study it.
And that's what may be at stake here. That's why scientists are interested in studying interspecies communication and closing the gap between us and them.
I think if we could talk to animals, it would really change our relationship with them, because people would realize that they are much more like us in many respects.
We are taught with our culture that we're so special and superior to other beings. When people see the chimps signing, it's like the chimps are reaching across that imaginary boundary that our culture has put up. For a lot of people, that just helps them to widen their circle of compassion.
It's going to really perhaps end what Lauren Isley has called the long loneliness of us being the only species that can communicate with each other. It would be very exciting to be able to communicate with other species on this planet.
If we were ever able to have a conversation with an animal, we'd first need to decode the sounds and movements that they make when communicating. This would be our Rosetta Stone, the groundwork for being able to talk back, a scenario that might change how we think, govern, work, innovate, and of course, eat. So how close are we to talking with animals?
So we really have to abandon our arrogance. And it's our arrogance that keeps us from communicating with other humans and other cultures. And it's our arrogance that has probably slowed our progress in understanding what non-humans are talking about.
We're already communicating with our animals in simple ways. If we then ask the question, how close are we to having a more sophisticated dialogue or exchange with other animals, I would say we still have a long way to go, and we're just in the infancy of understanding how to do it. And I think it really requires decoding more of what they're doing in their own natural systems and finding ways of incorporating that into what we want to create as a shared code. So it's complicated, but it's intriguing.
Thanks for watching How Close Are We? Let us know in the comments what topics you'd like us to cover in future episodes. If you want more How Close Are We, click here to watch our playlist, and don't forget to like, share, and subscribe. We've explored the jungles, the deserts, the Arctic, even the moon. But one place still remains a mostly uncharted mystery: our oceans. Oceans cover about 70% of Earth's surface, but we know more about the geography of Mars than we do about what lies on the bottom of the sea. But all that might change. Around the world, people are looking to finally reveal the secrets of our deep oceans for both scientific and economic gains. So how close are we to completely mapping the ocean? For thousands of years, people have taken to the seas with the goal of finding out just how deep our oceans are. This mainly consisted of tying a weight to a long rope and throwing it over the side of a boat. This is actually how we discovered the deepest part of the ocean, the Mariana Trench. Since then, we've obviously advanced with our technology and have already used satellites to map the entire ocean. Kind of.
So the way that they do satellite mapping of the ocean, they use altimetry. So as the satellite's passing over an orbit, if there's a higher concentration of rock or seamounts or anything that's beneath the ocean surface, the increased gravity actually causes some of the water to collect around the top of it, and they can measure the different heights of the ocean surface, and using certain algorithms and processing that data, they can actually get a decent representation of what it's like down there.
But decent isn't good enough. Satellite mapping only gives us about a 5-kilometer resolution of the ocean floor, meaning we can see features and objects larger than 5 kilometers across. To put that in context, most of Mars has been mapped to 6 meters, and almost all of Venus and 100% of the Moon has been mapped to 100 meters. Less than 10% of our oceans, and maybe closer to 5%, have been mapped to this level of detail.
That really is disappointing for a marine biologist, really disappointing for anyone who's thinking about doing business on the oceans, managing the oceans, thinking about how to get what we need from the future of the oceans. We're sort of fumbling around in the dark.
Having a detailed map would greatly change how we use the ocean. It would help with safety, like charting potential hazards that could take down a ship. It could lead to more accurate climate models, better understanding of tsunami dangers, and improved weather predictions. It would help with laying down ocean cables, fiber optics, and pipes. However, it could also help advance the exploitation of the ocean's natural resources, like those precious metals used to create your cell phone. But having a detailed map will help us better understand how to protect the ocean when the inevitable rush to further exploit it begins.
The International Seabed Authority, which is in charge of overseeing seabed mining on the high seas, as part of its charge is to set up some areas of special biological interest that will not be mined, and putting them in the right places, and places that matter for biodiversity and matter for ocean function, requires knowing what's down there. So you don't mine, for example, a rainforest and put your protected area in a desert, right?
So ocean mapping may be this double-edged sword. On one side, people are trying to map the ocean to help understand and protect it, making geological and biological discoveries along the way. The others are trying to understand and exploit it, potentially harming the ocean floor as they go. But these two factions might work together to achieve a goal that could see both sides benefiting.
How do you manage what you don't understand? We can map out things like manganese nodules that have the potential for copper, nickel, and cobalt. We depend on ocean mapping before any kind of oil exploration is done. They must map the seafloor, both the surface and the subsurface of the seafloor. And in this case, here we're going to get a full understanding through mapping of what's there, and then can set up the appropriate management approaches.
So if everyone wants this map, why hasn't it been done yet? Well, it'll cost a lot of money and take a lot of time, maybe as much as 200 ship years.
With the current day technology, it would take about 200 years for one ship to map the whole ocean, or 200 ships, 1 year. And the question is the cost. We've estimated that to map the entire ocean at a reasonable level of resolution would cost on the order of $3 billion. And you'd say, wow, gee, who would ever spend $3 billion to map a planet? And I point to the fact that we've sent missions to the moon, which costs on the order of $600 million or so, and mapped the moon much better than we mapped our planet. We send missions to Mars, many missions to Mars. Each one of those missions costs between $2 and $3 billion.
One way to cut down on cost would be to do it faster, and the good news is that's the plan. What started as throwing a weight over the side of a boat has turned into utilizing acoustic waves. By sending hundreds of laser-like beams of sound into the ocean and measuring how long it takes to bounce them back, scientists can more accurately image the ocean's depths.
On the other hand, we're also trying to develop techniques to speed that up, to do it more quickly, and to do it maybe with autonomous vessels, with vessels that will be more efficient, that you don't have to have a crew on, and send autonomous vessels out for months at a time, and let them start collecting the data.
To put out drones that would go out and do it autonomously, that's a new forefront that's developing at the moment, but that's kind of still in its infancy, and the amount of drones that we need to go out to perform this, that's something that they're still building on.
So yes, one day in the near future, our oceans may be teeming with underwater drones or crewless ships crisscrossing the planet, collecting and sending data that will be transformed into a 3D map of our oceans. which is another hurdle we need to figure out. What do we do with all this data?
There's also a major challenge of trying to amass, collect, and synthesize this data. It's one thing to have the data stored on 500,000 hard drives on 500,000 vessels, but you need to get it put all together in the same place.
And one group, the Nippon Foundation JEPCO Seabed 2030 project, is looking to lead that fight. They're aiming to gather all the bathymetric data and produce the world's first highly detailed ocean map, and do it by 2030.
It's amazing how every time we go on a map in the unknown waters, we find something we didn't know about. And it's that kind of discovery and exploration that really drives at least me in terms of ocean mapping.
And it's that passion, along with their hard work, that has